All right, class. I just want to talk real quick about the kits that we just got today. In this kit, I mentioned that there were 2 cards, and don't lose these cards. These cards, one's are for resistors, and one is for a download. And these downloads, there's a zip file. If you go here and pick our kit out, we'll end up with a zip file. I'll either include that on the announcements, or you can go to the website and get it. And that zip file is just this zip file listed here. We'll end up extracting this. I'll kind of show you what's inside here. So just a simple extraction. You can either put this on your desktop, you can put this somewhere where you actually want to save it. You can just hit that browse thing and go through your file directory. Have your parents help you if you need that. Right. And so in this, this is just the Arduino software, which we already downloaded. We end up with code, datasheets, libraries, and a basic PDF. In this PDF, we can look at it quick. This is a kit. This is your kit PDF. And it tells you pretty much everything you need to know. If you followed this, you'd get through all of the components in your kit with all the basic lessons. You can follow this PDF along with this code for anything we did not cover in this class or will not cover in this class. But in this, there is a bunch of lessons with a PDF to follow for other things you want to learn about. But the most important thing here is, the data sheets. So this is where all of the data sheets live for all the components that are included in your kit. So everything that's on this thing, all your data sheets are located here. This becomes important when we're building circuits. Now, I'll walk you through how to build circuits, and you won't really have to do the math or look at these, but we will go over these things so you know what I'm kind of talking about, right? A lot of the things you probably won't need these, but when it comes to the LEDs, we can look at the quick LEDs because the LED is the next thing that we're going to be working with. This is just a basic data sheet about our LEDs. Right now we have super red LED, right? And if we go down the parameters section, we have the symbol, we have max, we have typical, units, and test. So if we look at the forward voltage, we can look at the max voltage for this item is 2.5 volts. The typical voltage is 2 volts. So if we go anything above 2.5 volts, we'll actually burn out this LED. So typical voltage is 2 with a tested 20 milliamp. So 2 volts, 20 milliamps, which is 0.02 amps. So 0.02 amps is obviously a shifting of the decimal scientific notation. We can go over that if we need to. All right, so we'll end up using that. As you can see, there's a yellow LED and there's a super green LED. In your kit, we have this little bag. As you can see, we have yellow, we have the red, we have the green. And when we get to the green, we can look down at the forward voltage, and we end up with a max of 4 volts, 3.6 volts. So all of these aren't the same. They definitely accept different voltages, and this pretty much all is 0.2 amps. If you look at all this data sheet, everything has 0.2 amps. And this one has slightly different voltage, as we can see here. So that's just going over that data sheet quickly because this is the next thing we actually will go over. So just important thing to look at is these data sheets, just that you have them per thing. Some of them are hard to read. Some of them are easy to read. You can always ask me questions if you do have questions about these things, but we will go through this in class with each item, and we will show you things as we go. So that's just our little kit. It has your code it has some libraries in which we might need, and it has our data sheets. So moving on. All right, I just want to talk quick here. So this is our board, and we're going to go over the circuit we're going to make. And we're first going to draw this out on a piece of paper and do the little math that we might need. So as we looked on the data sheet, we had LEDs that ranged from 2 volts to about, I don't know if you can read that, 3.5 volts. Hopefully you can read that. So that was our range of voltage. And we have 5-volt logic. When we talk about these boards, some boards are 3-volt logic. This one is a 5-volt logic board. So any signal coming out of these ports is 5 volts. So we have 5 volts. We have 5 volts from the board. Okay. Some components in our kit might be 3-volt logic. Some components in our kit might be 5-volt logic. But the Arduino itself deals in 5-volt logic. So this is 5-volt logic. So we have 5 volts coming out of any of these pins in the board, right? And so with that said, we're going to draw a little circuit here. And so in our circuit, we're going to have an LED drawn like this. That's our little LED. You probably can't see that. I just wrote LED really small. So out of that LED, we have a positive and negative. We have one pole that's long, and we have one pole that's short out of that LED, right? And so if we're sending positive signals in, we're going to go from our positive, which is going to be one of these terminals where we're going to send a signal to it. And if we were to directly plug it in, that's 5 volts directly into our LED. We'll burn it out. So we end up with wanting to put a resistor so that we only put that said 2 volts or 3.5 volts in which we're dealing with our LED from our data sheet. So that's our little resistor. And then that will come in and we'll go to some pin. In this case, we're going to say pin 8 because that's what we're going to code it to. So coming in from pin 8, we'll have our resistor, we'll have our LED, and then we'll end up having to put this to ground. So if this is just a drawing, we'll go to ground. Okay, so we have this basic pin 8 resistor, LED, ground. And ground will come from either side of this board, whether it's over here on this ground or this ground here. And our pin 8 is right here, and that'll come out pin 8 to resistor to LED, LED to ground. So with that said, if we have a total voltage, so we're going to write this kind of out so you can kind of see what the math we're going to do here. We're going to go volts total, right, equals the sum of all the voltage. So we have voltage of the resistor plus voltage of the LED. So we know the voltage at the LED we want about 2 volts. So we can plug that in and we can say 2 volts here plus the voltage of the resistor equals total voltage. We have 5 volts from the board, right? And so voltage R. We end up with, we can minus 2 here, minus 2. We end up with VR. So we have 3 volts equals VR, or more written like this, 3 volts right? So we have 3 volts. That's what we need VR to be. We need 3 volts to be sucked up here so we have this. So we end up with, we talked about Ohm's law, right? In Ohm's law, we have V equals IR, right? In this equation, this is just symbols. This is voltage, current, and resistance. This can be rewritten if we say divide by R on this side and then divide by R. This is algebra. I don't know if you guys have covered this or know this math, but this is just simple math. And so if we divide by R on each side, we end up with these R's canceling out, and we have VR on this side equaling I. Or in this case, you can rewrite it as I equals V divided by R. So we can do it that way. Otherwise, we can do it this way. We can take V equals IR, and if we're trying to find the resistance, we can divide by I. The I's will cancel out, and we end up with R equals V divided by I. I hope that makes sense. You kind of see that, right? So that's basic algebra. You might see this later in your schooling, but right now we just have the equations either I equals VR, V equals I times R, right? Or R equals V divided by R, right? So R equals V divided by I, right? Which is current. So we know that the current of these tested LEDs is 0.02 amps, right? So we can take this variable. So this is I. We know our voltage. that we want across this. So we know our V, which is 3 volts. And we need to know the resistance. We need to know what this resistor is. So we're looking for R. That's our question mark. We're looking for R. So we can take this equation down here and just plug in our parameters. And if we plug this in, we're going to rewrite this over here. R equals VI, which equals 3 volts divided by 0.02, which equals roughly 150 ohms, right? So we have 150 ohms. We want to work in amps, not milliamps, not any other sub-amp thing. We want to work in amps, and we want to work in volts. So that it works out evenly, so that the units work out to calculate to ohms. All right, so we have 150 ohms. That's what we want to stay in. So ideally, we want to be somewhere in the range of 150 ohms, or if we want to resist more, we can go all the way up to probably about 330 ohms. The more resistance we have, right, the more resistance we have, whether it's 150 ohms or 330 ohms, the brighter the LED is. So if we have less resistance, the brighter LED is. If we have more resistance, less volts goes through that, right? So higher the resistance, less volts goes through here to this. So we can have a range from there. So our basic will have pin 8. We'll have our LED within this range. Or sorry, we have our pin 8. Sorry, misspoke there. And we'll have our resistor within this range. And then we'll have our LED of 2 volts. And then that's the ground. So we're going to go over to the board and build that. Okay, so when you come into class next week, these are the items I want you to pull out of your kit. You'll instantly need your breadboard, which will be in this box, but we'll just need the breadboard. We'll need our pack of resistors. We'll need the LED bag that also has buttons in it. And then we will need our Arduino board and our cable. And we are, just as we discussed before, we're going to build that simple, hopefully I can get this in here, pin 8 to ground circuit. So pin 8, resistor, LED, ground. And I'm going to go through and walk through that so you can see it here built on this, and then you'll build this in class and we'll walk through it again in class. This is just a iteration of what we're going to do, and we're just going to reiterate exactly this in class. So we have a bag of resistors. If you left yours in with me within class, I will probably write down all of these on each resistor so you don't have to use your cheat sheet code thing, and we can just grab them instantly. Don't worry if you took it home. I'll definitely get this information to you so you don't have to actually look through everything. So anyways, we wanted that range between 150 to 330 ohms. I'm going to end up taking these 220 ohm resistors. I'm going to end up taking one of these off of here, and we're going to need 220 ohm. We're going to start with the red LED because that's the one we calculated for. Now, I did the math. We can essentially use the 220 ohm for all of these LEDs. Some of them will just be brighter, some of them will be dimmer, but we'll just start with the red LED first. And we have, as you can see, we have a anode and a cathode. We have a negative and positive and negative, right? And we're going to stick that in our board. If we watched on the video on this, these are linked together, and then these are linked this way. So if we see this, we want to stick a long end in there and a short end in there, like that. Then on our board, we wanted the resistor. I'm sticking this in one end into the long end. Remember which side we stuck the long end into, just like that. So remember, those are connected this direction. So as you can see, we have the long end stuck in there. And then I'm going to go ahead and stick this in a random spot over here, right? And then I'm going to grab, I apologize. You'll also need your jumpers. So that's the other item that you'll need. I'll write up all on the board of what you need when creating this circuit. So as in our drawing, we had, take a quick look at that again. We had our pin 8 to resistor to LED to ground. So we have pin 8, stick a lead in pin 8. We'll take that lead, stick that into the line that has the resistor. So just like that. So pin 8 to resistor to LED, and then LED to ground. So in this case, we can take the ground from here. Doesn't matter what color. In this case, we just go ground here. That's ground. And we can stick that in the side that has the negative. So it's basically just that. We have lead 8 into the resistor, resistor into the long leg of the LED, short leg to ground of the board. And that's our basic LED with the 220 ohm resistor build. All right, and then we're going to move into plugging this in and actually programming this. The basic thing we programmed here with the LED in here will work for the circuit. So we'll plug that in and we'll look at that code and mess with that code for this LED.